Hopefully you've had a chance to try this problem on your own. Now I'm going to walk through my solutions for it. So this problem is looking at that heat transfer between from a hot object to a colder object. So in it, we've got whiskey stones that have a mass of 9 grams, and they have a specific heat of 0.75 joules per grams degrees Celsius, and they're at 0 degrees Celsius. So we have these cold whiskey stones that are dropped into a glass of whiskey. And that glass of whiskey is at room temperature. It's 40 grams, it's at 25 degrees Celsius. And since it's a combination of alcohol and ethanol, we're actually just going to do an estimate rather than like experimentally determine the specific gravity of it. And so we're going to place it somewhere in between the two and call it 3.25 grams per joules per grams degrees Celsius. And the goal here is to calculate the final temperature of the whiskey and it'll be the stone as well. So when we see this, calculate the final temperature of the one of the objects, it's really assuming thermal equilibrium. And that thermal equilibrium is when our temperatures are the same for the whiskey and for the stone. So let's collect all the information out of this problem. Again, I really like doing this with a drawing. It helps me quite a bit. So I've got a glass. It's not a very pretty glass, but there we go. With my liquid and with my stone. And the stone is cooler than the whiskey. So I'm going to see heat spontaneously transfer from the whiskey into the stone. Now, let's track the information that we have here that we've been given. So for the actual stone, I know I have a mass of 9.00 grams, and then I'm going to list my specific heat, which is at 0.75 joules per gram degrees Celsius, and my initial temperature, which is that 0 degrees Celsius. Now, looking at the whiskey side of it, I have information about mass and specific heat and initial temperature as well. So this time the mass is going to be the 40.0 grams. The specific heat is that 3.25 joules per gram degrees Celsius. And my initial temperature is 25 degrees Celsius. And in all of these, I want to now know what is that final temperature. And that final temperature will be the same for the whiskey and for the whiskey stone. So that'll simplify our problem solving a little bit. Okay, so now that we kind of have our information organized, we can actually start looking at what our equation is. And so the idea is we are focusing on a stone and the whiskey. For some reason, to me, the stone is how I'm going to reference the system, but it really doesn't matter which one you choose. What does matter is that they are opposite signs. And so the heat that is absorbed by the whiskey stone, which I'm going to abbreviate W, will be equal to the negative of the heat released by the whiskey. And I realize I just used the same subscript for both. So we're going to do the heat of the stone with an S is equal to the negative of the heat of the whiskey with a W. Much better. So using our equation, right, that heat is going to be equal to mass times specific heat times the change in temperature. I can substitute that Q for heat with the mass, specific heat, and temperature, which is something that I know about. So I'll have the mass of the stone times the specific heat of the stone times the change in temperature of that stone is going to be equal to the negative of the mass of the whiskey times the specific heat of the whiskey times the change in temperature of the whiskey. And remembering that change in temperature is always the final temperature minus the initial temperature that we start with. Okay. So at this point, then I'm just going to plug my values in. I know I'm looking for final temperature, so I'll be sure to highlight that in my equation. So I'm going to start with my stone side and then do the whiskey side second. So I'm starting with this 9.00 grams of my whiskey stone times my 0.75 joules per grams degrees Celsius for my specific heat. My final temperature then will be I'll subtract from my final temperature that 0 degrees Celsius. And that's going to be equal to the negative of my 40.0 grams of my whiskey that I have times its specific heat of 3.25 joules per grams degrees Celsius. And then my final temperature subtracting 25 degrees Celsius. Okay, and then that goal is to isolate the final temperature and calculate it. So to do that, what I'm going to do is I'm going to multiply out the mass and the specific heat and then distribute that into my parentheses that captures the information about my change in temperature. And so I'm going to go ahead and multiply that and distribute it out. So it'll be 9 times 0.75 times TF minus 9 times 0.75 times 0. I'm going to pause and write that all out and then continue on. All right, now that I have simplified this equation a little bit by multiplying out my values, I have 6.75 times T final is equal to negative 130 T final plus 3,250. So to solve this, I'll add 130 TF, or final temperature, to both sides. And that's going to give me 136.75 TF is equal to my 3,250. Dividing out that 136.75 on both sides will get me an isolated temperature, a final temperature on one side of the equation. And so then plugging this into my calculator, I'm going to get a value that is 23.8 degrees Celsius. So the temperature of the whiskey really hasn't changed that much. And this may very well be due to the fact that we have a small whiskey stone for a large mass of whiskey.